I'm going to hit the record button. Looks like it's a small group today, but it was a long weekend last week, so I had to shift the sessions to Tuesday and Thursday. I'm not sure everybody saw that notice. It was on our calendar, but nonetheless, a couple of housekeeping items before I move into the Python unit. Firstly, the next progress report or report card is going to be sent out to students and parents tomorrow. So if you've got any assignments that are sitting around that you haven't submitted yet, please get those in so I can assess them and get you some feedback and include them on that progress report. Assignment 9 was due yesterday, and that was steps 15 to 18, I believe, for Reborg. Assignment 10, which is the last 2 Reborg programs, is due tomorrow. So just sort of some house cleaning stuff, and then we're moving full bore into Python today. So I don't want to retread too much ground that I've already taken care of with the tutorial videos for Python. But what I want to do is maybe elaborate on a few of the concepts and show you actually in PyScripter how some of the comments and statements and introduction to data and variables and stuff like that, how that actually works on Python. So that's where we're going to go today. And we're going to have several more live sessions on Python as we move forward. It's our last unit. It's our biggest unit, and it's where you get to use all of the skills and all of the abilities and the ideas that we've been practicing from scratch and mostly Reborg. You'll find that a lot of the structures that we used in Reborg are very similar to the structures that we use in Python, and that's by design. Reborg is built with a Python engine and uses a lot of Python commands, and a lot of them will actually transfer right over directly. There's certain things you can do in Reborg that that are slightly different to do in Python, but the ideas are the same. Just what you have to type into your code or the syntax is a little different. So if you're comfortable with Reborg and you've done the Reborg assignments and readings and learning, Python should be a relatively seamless transition. That being said, there is a lot of material in the Python section. That's why I was so adamant that people stick to their class schedule and make sure everything with Reborg is done. If you can look here on these are all the things we have to do in Python. And a lot of them are little programs, and if you understand the fundamentals, you should be able to rip some of them off within 10 or 20 minutes. But there are also projects on here that are going to take several hours because there's more problem solving required, there's more coding required. So don't take it for granted. Get started as early as you can, and make sure that you are putting in your 2.5 hours every day. Make sure that you are asking questions by email. Make sure you're watching all the videos and you're reading all of the materials that I put up here for you, because anything that we need to do in the course, anything that is assigned as a program to be handed in or as part of the unit exam, is covered in the videos and in the tutorials and in the web links that I post. So make sure that you're going through them in order, and make sure that you're doing a good job of practicing your skills along the way. We haven't had any unit exams yet in this course. I have 2 large unit exams. They're both in the Python section. The first of those is going to be completed after we get through 4.4, and that'll be sometime early next week. The exam is not scheduled till a little bit later, possibly the next week, I think. The exams are open for about 5 days, so my recommendation is to start early on them. Don't leave them to the last minute. If you really know your stuff, you can probably get through the exam in an hour, hour and a half. Some people take significantly more time than that, but that's fine. That's why I have them open for so long, but definitely do not leave them to the last minute. You can save your progress on all the exams, so you don't have to do it all in one session. You don't have to do it all in one day. You can do a little bit of the exam, save it, come back the next day, and so on. Both of the exams in the Python unit have 2 sections. The first section is a theory-based section where it's mostly multiple choice. In fact, for the first unit exam, the first part is all multiple choice. It's basically testing your understanding of concepts and have you done the reading? Have you practiced your skills? If so, you should be fine for that. And they are all open book and open internet, but there was absolutely no copy and paste, and there's no collaboration, so you can't work with peers or other people on these exams. It has to be you alone, but it is open book, and all the answers and all of the skills are contained in our class materials, so you should be able to handle everything on the exam. So the first part's the theory portion. The second part is a practical portion where I will give you a certain problem or a series of problems that need to be solved. So you basically have to create a program and test it and make sure it's commented and everything's working properly. And then you would submit that program or those programs. I think there's 4 in the first unit exam. As you would normally submit assignments, there's a page dedicated to the practical exam, and that's where you would hand in your files, and you can zip them up just like you did the Reboard files, or you can just hand in the Python files directly. It doesn't matter to me. So that's what's going on for the exams. And then there's a second unit exam that comes right at the end of the Python learning that takes us basically from 4.1 all the way through to 4.8. So it's kind of a cumulative exam for the Python. And those 2 exams are quite heavily weighted in the course assessment because they do test pretty much everything in the course with regard to ideas, but the actual programming and structures will all be from Python. So you're not going to see any Reborg or Scratch concepts on those exams. You've already had some quizzes on that earlier in the year. So make sure you prepare well for the exams. Make sure you start early. Make sure you pace yourself. Make sure that you are not leaving it to the last minute. I can't answer any questions specifically about the exam, so you're gonna have to use the materials to make sure you've got your answers correct. I can clarify questions if you're having trouble understanding what it is that you're supposed to solve or what the problem is. I can try to clarify questions, but I can't give any answers. I can't give skeleton code or prompts or anything like that. It's supposed to be a test of your learning, and that's why they're there. See if I have anything else to add about exams. I don't think so. Oh, they are not going to be moved or excuse me, or you're not allowed to submit them late. They are not allowed to be rescheduled. I've allowed you to hand in things late in this course, and obviously there's no penalty. I've encouraged you to use my feedback to improve your programs and resubmit them for better marks and increased understanding for you, and I stand by that. I think that's a good way to learn. But the exams are one time only, and they cannot be postponed, and they cannot be handed in late for any reason. So because you've got basically 5 full days to do the exam, there shouldn't be any excuses for not being able to finish it on time, and try to make that very clear up front just so there's no questions about that later. Okay, so without further ado, I'm going to move into our Python unit and take you through the first sort of getting set up in Python and making sure you have a good code development environment and you have access to the materials. And then I'm going to go through the slides and some examples from 4.1 and 4.2 just so we can get going in it. And again, I don't want to retread too much what I've already covered in the tutorial videos, so I may breeze through these slideshows, but I'll make sure that I show you a couple of the steps for each of the concepts so that you can see it at play in Python. Okay, so at the top here, hopefully you can all see my screen. I will maybe zoom in just a bit. So at the top here, we've got all assignments for Module 4, order of completion. I've got a recommended order of completion for assignments in this class because the skills build on each other. It's kind of just like step 1, step 2, step 3 board. It doesn't make sense to do them out of order. So I took them from my document that I showed you earlier in the year, and this is the order in which I think you should do all of the assignments. It shows you what sort of concept section they fit into. It shows you how many marks are for each assignment, and gives you a recommended order for that stuff, from the easiest to the hardest, right? You know, it's expected when you get down to the bottom here that you've got all the fundamental skills under your command, and you can solve some more difficult puzzles and problems. And you don't want to jump into it too early. You want to make sure that you've built your skills up using these other assignments and learning materials. So a lot of students like to print this off and use it as a checklist. And I went through that earlier in the year. The entire list of assignments for the whole course is, I believe it's in learning modules right at the top. All assignments for course, it's right there. So if you just want a PDF version that you can print off and use for a checklist, that's what it looks like. Just print it off, and check as you make your way through the assignments. So a lot of students find that to be a helpful way of going about it. You may not, it's up to you. And that's the first link at the top of the page. Whoops, go back into Unit 4. So that's the first link. Definitely look it over. If you want to print it off for a checklist, that's great. If you don't, that's your decision as well. And then the second one I've got is setting up what's called an IDE. It's short for Integrated Development Environment. And you can make Python script just in a text document, a notepad or word processor, but it's not the best way to do things, and you don't have a lot of the supports if you do it that way that you have with an IDE, or again, integrated development environment. So that's why I strongly recommend that you download and install one of these programs, depending on which machine operating system you're using. There's Windows versions, Mac versions, Chromebook versions, and most of these can be found in Linux as well. I don't think I have too many people using Linux, if anyone, but there's lots of options here. The one I use is PyScripter. So this is the one, I've got it noted as recommended. PyScripter is my favorite IDE. It's very stripped down. It's very easy to use. There's not a whole lot of stuff that you can kind of get lost in, because some of these integrated development environments kind of look like the cockpit of a 747. There's so many tools and so many little things you can do and buttons you can push that it can be a bit confusing. So I like using PyScripter, and Thoni is another one that's very simple, and I've used in this course before. So those are the two that I recommend. Thoni is good in that it's available both for Windows and for Mac. So that's, that one works well in whatever you're doing. And PyScripter is, from what I can tell, only available in Windows. And but if you're running a Windows machine and you want your screen to look exactly like my screen, that's the one that I'm going to be using. That being said, Thoni is very simple and it's very similar. If you want to use Thoni, that's great. There is a difference between what you have to do to get going with Thoni and what you have to do to get going with PyScripter. Thoni is a program that you can download and install and then not have to do anything else. You just download it, install it, and then open it up, and then you should be able to work in it. Whereas for PyScripter, you have to have Python installed on your computer first. So it's like you have to install two different things. You have to install Python, the language itself, so your computer can interpret and run Python code. And then you also have to install this PyScripter from this page. And then if you have both of those things downloaded and installed, you should be able to just open up PyScripter and it'll work. For those people who aren't sure if they've got Python on their machine, or you don't know, or you want to find out, if you download this PyScripter program from this link and open it up and it doesn't let you do anything or it gives you an error, you probably don't have Python installed in your computer. So in order to fix that, you just go to the website python.org. Okay, you just Google Python, it'll be the first thing that pops up. And then there's these downloads. So there's a download section, and then you just pick what your operating system is. You got Windows, you got Mac, other platforms. Linux is probably in there. So if I go to Windows, it says Python releases for Windows. Okay, so you would probably go down to the one that says the Windows installer, and I would use the newest version, 3.9.5. So Windows installer, either the 32 or the 64-bit. If your computer's brand new, or even in the last 2 or 3 years, you probably want the 64-bit version. If your computer's older than 3 years, maybe try the 32-bit version. Both, if you're not sure, go with the 32-bit version, it'll work. And this is the sort of thing that you just click on it, it downloads it to your machine, so you can see it downloading down here. And then when it's done downloading, you just double click it and it'll step you through the install process, and that will install it. If you have Windows 7, will the programs work? That's an excellent question, because Windows 7 or earlier, you can't use version 3 point something or other and later. 3.9 it looks like. So if you have a machine that has Windows 7 or something before Windows 7, you're going to have to go down to this one. So this is 3.8.8. That would be the newest version that you could use. It won't look any different. It'll operate in the exact same manner. But if you've got Windows 7 or earlier, download one of these two. The 32-bit version, I would think, if you're running Windows 7. Okay, so that's an excellent question, and that's noted right up here. Cannot be run on Windows XP or earlier. Windows 7 is after XP, so you're fine there. and then 3.9, Windows 3.9. As long as you've got Windows 8, 9, 10, and beyond, you're fine with 3.9. Thoni works on all of them. So yeah, Thoni's a good option for you if you're at all concerned about it. But you can absolutely install Python if you've got an older machine. You just have to make sure that you pick the right one. If you got any questions about that, you just let me know and I'll help you install it. So that's python.org, and the instructions to kind of get going should be pretty clear in that material that I've got here. If you want to do it just on the web, that's fine too. You can find lots of Python interpreters and IDEs that run right from the web. Replit is one of the big ones. It's repl.it, and this link right here will just take you to what we call a development sandbox, and then you can pick the language. There's lots of languages, but you're going to work with Python, and then you can actually do your code on one side of the screen, and then hit run, and it'll run on the other side of the screen. Print hello world. You see it printed hello world. And from here, you can save your programs and you can download your programs and whatnot. I would recommend, if you want to learn this the best, I would recommend using PyScripter or Thoni. But if you're just having no end of trouble getting them installed, or if there's some other problem, you could certainly use an online sort of developer or sandbox. You do have to save your programs carefully, and you have to make sure that you're able to upload them to me. I have had some students in the past that have used web-based Python interpreters and have not realized that they're not been saving their programs. So even if you're not sure how to save a program on the actual website, copy your code, paste it into a Word document, save it that way, just so you make sure you have a backup. For Replit, you definitely would want to sign up, because when you sign up and save stuff, at least it saves it to your account. Whereas if you just play around with the one right here without signing up, it's obviously not going to save it. It doesn't know what to save or where to save it or who you are. So you got to be careful that make sure that you're always saving your files properly. Create a folder for your Python projects. Make sure you name them appropriately, so you never have any trouble finding stuff when it's time to hand it in. There was another one, Code High School, I think. I don't use it, but I think Code High School had a pretty good online sandbox. It might just be for Java, but I'll just have a quick check here. There's a sandbox. You create a program, and yep, for sure you can do it here. Python 3, create program, and another one that you would want to create an account for. So print hello world. You could save your code. You can run your code. Okay, see hello world, and you can save it. Okay, so I'm logged in, so it's probably saving it under my account. I would also assume that there's a way to download. Again, I don't use Code High School very much, so you might have to play around with it a bit, but it's certainly something you could use as well. The reason I don't like using these online ones is because, as you found out from the Reborg unit, it's a huge deal being able to go step by step through your programs in order to debug things, and it becomes actually even a bigger deal in Python. So you are absolutely going to need to run a development environment or interpreter that allows you to step through your code line by line. Otherwise, you're going to have a heck of a time troubleshooting when things are wrong and identifying where in your program you need to fix things. Another benefit of having an integrated development environment is that it has, most of them have code completion. So you don't have to type as much. So for instance, if I'm going to print something, I start with P, and you notice that this little pop-up comes up here, and it shows you all of the things that you can do that start with P. So I can just use the arrow, go down to print, hit enter, and then it puts print in for me, and then I can put in what I want to say, hello world, and then I don't have to type as much. Also, if you create a variable, you don't have to worry about this yet, but just an example. If you create a variable, let's just say I'm going to create a variable called word. I'll call it word1, and then I want to access that variable later. I want to print it, so I want to print word1. Okay. Now when I type in W, it also remembers that I have created a variable, and we've done variables in Scratch, so you should be familiar with that. Those were the orange blocks. It remembers that I have created a variable called word, so it points to it on the list, and I can click on it, or I can use the arrow keys. I hit enter, and that way it helps you keep track of your variables a bit better. You see down here it printed word because word one was word. So if you program and a lot of variables at the top, you can't remember what they were called, if you can just type in even the first letter or two, it pops up the only possibilities. Hit tab. You can hit enter or tab. Tab tends to be quicker, and then it'll fill it in for you. So that's called auto completion, and it just allows you to speed up your coding a little bit because you don't necessarily have to type out every single word if they're commands or variables or things that are built into the program. So that's really handy. But the biggest thing about using an IDE in this class is the ability to keep track of your variables down here. It might be in a different spot on your program, but you can drag all these windows around. You can move them wherever you want, kind of deal. You can keep track of your variables so that you know what each variable's name is, and you know what type of data it is. This is a string, which just means it's a word or characters, and it also shows you the value. So let's say I create a new program and I create a bunch of variables. Let's x equals 5, y equals 5.5, z equals the word high. And then I have, let's say I have a 3-step program. I'm just going to print these 3 out. I would print x, print y, get brackets, print z. So I've got a 3-step program here. Well, it's going to print 3 things. I have 3 variables that I set up. It's going to print 3 things. But what I want to demonstrate is stepping through the code line by line. I could just run the code by hitting the green arrow, and it'll run, and it should run properly. It's, see how it prints down here, 5, 5.5, high, exactly what I wanted it to do. But let's say there was a mistake in here somewhere, and let's say I accidentally printed x twice instead of printing y. It doesn't break my program. It runs, but I'm not getting the output down here I wanted. I wanted to print out 5, 5.5, and high. It only printed out 5, 5, and high, and I mean the mistake is obvious right there, but on a longer program, it might not be so obvious. So this is why you want to be able to do step-by-step things. So for most of these, it's not just debug. There's a debug button up here, but a debug kind of runs it all at once and then gives you some recommendations. What you really want is stepping into and stepping through code. For PyScripter, it's F7, and I can't honestly remember what it is for thoni, but it's something similar. It's either F7 or F9 or something like that. So when you hit one of the F7 keys, you'll notice that it highlights in blue, and it's just like Reborg. It shows you line by line where you are in your program, and then your output will come down here in a line-by-line fashion as well. So my first step isn't really printing anything. It's just saying I'm going to have a variable named x, and its value is going to be 5. So after I run that step, I'm just hitting F7 repeatedly. So every time you hit F7, it runs another step. I'm on step 2, but if you look down at my variables here, you see that I've got a variable, and it says it's named x. It is an int for integer, because 5 is an integer, and the value is 5. So when I hit F7 again, now another variable pops up down here. There's one called y. It's a float, which is a decimal. That's how we refer to decimals. The value is 5.5. That allows z is a string to the word high. And now the first print line is print x, so I run it, and you'll see down here it printed out 5, so that's good. And then I print it again, and now I should be able to identify, oh, that's exactly where my error happened, and then I can go back up to my code, and it's usually the line before the one that's highlighted. So it's ready to run the z line, the print z line, but because I looked down and during my step through of this program, I realized my mistake was right here, I would then go up to my code and say, okay, what was the step right before that one? Oh, okay, it's this one right here, and I see my mistake. I printed x instead of printing y, and then I just keep stepping through my program with F7. It runs the last step, and hopefully I've been able to fix it. So now I've done stepping through my program. Now I can just test it by running it, and now it runs perfectly this time, so I'm happy. And the important part was I was able to step through my code line by line in order to find out exactly where my error was and to go back and fix it. So not all development environments have that feature, and a lot of the ones on the web either don't have it or it's kind of hidden. Again, you can use whatever you're most comfortable with, but there's a reason that I recommend these ones, and it's for things like code completion. It's for things like being able to see your variables in an easy way and being able to have, you know, more than one window open, and the code completion, and just all sorts of little handy things that makes it easier for your code. whenever you are coding something, make sure that you're saving it. Make sure you're using proper notation to save things. So for this program right here, I've done something, but I haven't actually saved the program. It's like opening up a Word document and typing a whole bunch of stuff and then just closing it down. You didn't save anything, so it's going to be gone next time you log in. So make sure you're always going up to File and always going to Save, and then make sure you're saving it in a location where you have, maybe a Python folder. And then when you're saving things, don't forget, we don't ever have spaces in file names or variable names. So you're going to want to use either snake case or camel case. So let's just say this is assignment 1. I might name it something like ASST, short for assignment, and then maybe the capital O1, something like that. No space in any of the between any of the characters, but usually use capital letters. So assignment 1 for Mr. Dunbar. You don't actually have to name things like this. I'm just showing you that you capitalize certain letters to indicate that they're different words, and that's how you can do it without having spaces. And then also the other way was sorry, that was camel case, and the other way is snake case. We use the underscores, so that would look something like this: assignment 1, Mr. underscore Dunbar. You see how there's little underscores between each of the words. That's another way that you can have a file name without a space that will still show you sort of individual words, because it's easier to understand what the program is or what it does if it's named appropriately. So that's the two options there. Another thing I might recommend is for more difficult programs where it might take you 3 or 4 days, you might want to save multiple versions. And I went through this when I was talking about Reborg as well. You might want to, you do a bunch of work one day and you save it as, I'm just going to save it as assignment 1, Mr. Dunbar. You might consider opening that assignment up the next day and then right away going to save as, and then instead of saving it as the same name, maybe you put assignment 1, Mr. Dunbar, and then you put like capital V2 or something for version 2. So now you've got a copy of the work you did yesterday, and then you've got a new copy that will cover all the work that you're doing today. So if you ever lose or corrupt one of those files, you can always go back a version and you don't lose a whole bunch of work. So that's not a bad idea. You certainly don't have to do it with any of the smaller programs, but if there's a bigger program that you're working on for multiple days, having a couple of different versions is a really good safeguard, just in case one of them gets really screwed up, either with your code or maybe the file gets corrupted or deleted or lost. Then you don't lose as much work. Can you visually see your program? Now we've moved into we've moved into syntax-based coding, and the output for this unit is all going to be text. So we went from a highly visual environment like Scratch, where it was drag and drop and cats and stuff like that, to one that was kind of half and half in Reborg. You still saw the robot, you still controlled the robot, you had code on one side, but a lot of the code was built for you ahead of time. You didn't have to program Reborg to make it move or like to actually create the move code, and you didn't have to create code for certain conditions and whatnot. You were kind of half and half. You were coding some things manually, and then you were using a bunch of built-in stuff, and then you also had the visual element. Well, now we're on the strict syntax. You build everything. So your code is going to be text syntax, and your output is going to be text as well. Okay, now there are graphical user interfaces for Python. Once you understand the basics, you can extend it and take it further and use a lot more graphics programs. There's one built in called Turtle Graphics, where you're a little turtle and you can draw stuff and whatnot using your coding skills and programming. But that's something that we're not going to do in this course. You need to understand the basics of computer science and those 5 major principles. But otherwise, you're going to be overwhelmed when you go into larger visual environments. Now, you do more of that in Computer Science 30, but again, there's also a lot of coding that goes with it, and a lot of very syntax-sensitive code that goes into your user interfaces. So if you don't have this stuff, if you don't understand this stuff really well, you're going to struggle more with the graphical stuff than you are with just the text stuff. So you're going to see just text from here on in, but as far as output, the way I have my windows set up, this is where my code is up at top, and this is where it runs down here. So when I told it to print X, print Y, print Z, that's the 3 things it printed down here. So this is where you're putting your code in, and this is where you are seeing your code. And also you can get input So you can still get things from users, and you're going to have to get things in for users. So let's just say I tell the user type something in here, and then I'll try and print that out. So I'll print T. Okay. So when I run this, I'm just going to get rid of the old stuff. When I run this, sometimes you're going to see a box pop up, depending on what development environment you use. Sometimes it'll pop up a box like this with your instructions. Type something here, so I can type in whatever I want, and then when it prints or when it runs, it'll print that out. See there, right there, printed it out. Whoops. So the instruction was type something here, and then I told it to print it out. Sorry, I got to zoom out again here. I'm zoomed in for some reason. There we go. And so I told the user to type something in, and then they did, and then it printed it out. So, but you notice when I ran the program, it actually opened up like a pop-up box for me. Not every IDE will do this. Sometimes it just shows up down here in the actual interpreted code output window. So sometimes you're going to, depending on what you're using, you'll have input boxes for the user up here, and sometimes they'll just have to actually type it in down there. It depends on what program you're using. Okay, I got an error there because I didn't actually type anything out. That's another good reason to use a development environment, is that it will tell you if you have syntax errors. And we'll get more into error troubleshooting and how we can get around handling certain errors and certain bad inputs by users later in the course. But it is another thing that it's good for, in that if you do something wrong and it's obviously wrong, your program won't run at all. It'll just break, and it'll try to tell you why it's breaking and where the problem is. So it's saying straight up, line 1 is your error, and operation canceled is why the program crashed. And there's all sorts of different errors based on all sorts of different mistakes people can make while they're coding, or that people who are using your program can make while they're typing stuff in. And this sort of internal error checking can help you diagnose where the problem is and possibly how to fix it. So I'm going to move away from PyScripter right now, and I'm just going to open up Thoni just so you can see what it looks like. So as you can see, it's very similar. I usually have the background be black and the text be different colors, because if you're in front of a computer a lot of a day, you ask people who are designers, coders, people who work with drafting software, like AutoCAD and things like that. Having this much white shining in your eyes all day is actually not very good for you, and it can give you headaches and eye strain. So a lot of programs have the option to change the background colors so that they're black instead of white. I'm not sure how to do it on Thoni. It's in here somewhere. There you go. So, that's if you're wondering why some of my screens are black, it's a little easier on the eyes. I tend to spend a lot of my day in front of computers, so this helps me out. This is Thoni. You can see it's very basic. There's a lot of white space, but it has the same things, right? So I type my code up at the top here, and then when I run my code, just using the little green arrow, it runs it down here and shows you your output. And then it's also got the variable window up here. There's not quite as much stuff you can do on Thoni, but it's got everything we need for this class, and it's probably simpler than PyScripter, which is also actually pretty simple compared to some of the other development environments. I went here because I just wanted to show you. That you can do step-by-step debugging in Thoni as well, and I just wanted to check what the key was for it. So there's debug curd script. Again, that's not the one you want. It's step into that you want, because step into kind of allows you to step through your program, and it is F7 on this as well. So if you hit the F7 key, it will run your program line by line. Oop, I actually got to be on that. There we go. What's going on here? Stop. Whoops. Try that again. And this one. Let's go. Oh, I've got a very obvious syntax error, which is why my program wasn't running. There we go. That should work better. Come on, what's going on here? There we go. Sorry, for Thoni, it looks like you do have to hit the debug button and then you do F7. So it's a little different than PyScripter. PyScripter, you just hit F7 and it goes. This one, you got to click the little bug and then hit F7, and then it shows you this line's highlighted, and then So after that line runs, you can see over here, we've now got a variable, and the variable is equal to 3. It doesn't tell you the data type, but I suspect that you can change that if you want, so that it would tell you that 3 is also an integer. Another nice thing is for most IDEs, when you mouse over things inside them, it'll pop up and tell you some data about them. I've probably got that turned off right now, but I'll show it I'll show you what that looks like in PyScripter. So anyway, the point is you can still do the step-by-step debugging. It's running step-by-step. We're on step 2. I hit F7. Okay, it shows you that it's printing X, but X is actually equal to 3. So, you know, it might take you more than one F7 to get to the next line, depending on the program you're using, but it's going step-by-step. This one's going to go print, and then it's going to say, what are you printing? It's printing hi, and then it's going to go back and say, okay, I'm going to do the whole thing now. Don't worry about the none. And then you can see it's popping up down here every time I make a step. It's actually outputting it, so it's showing you the output down here. So it works in a similar fashion to PyScripter. Sometimes there's just different keystrokes, or it does it in a slightly different way. But once you have the idea of debugging down, it's good. So I'm going to go back to, and I say so a lot. I'm going to go back to PyScripter, and I'm just going to show you what I mean by mousing over things. When you mouse over things in PyScripter, it gives you really good information. So when I mouse over the T, it says, hey, this is going to be a global variable. This is an input statement. And then it also shows you how you build an input statement. You got to use the word input, then you've got to put a bracket, and then you've got to have self prompt equals none. And you don't have to worry about what that means right now. You'll understand those things a bit more as we move into the class. But the point is when you mouse over things, it gives you these little pop-ups that really help you. If I were to say that T is equal to 5 instead of getting the user to input something, and now I mouse over T, okay, you see it says global variable T of module blah 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 blah. Basically, it's just this is a variable named T in the program ASST1 Mr. Dunbar, and the type of that variable is an integer. So it tells me quite a lot about what T is just by mousing over it. Additionally, you can go over here and you can see in your globals. Oh, I haven't run the program yet. That's fine. If I run the program, okay, now you can see in your global variables, there's a T, it's an integer, it's a 5. So you can tell that down here by the variables window, or you can just mouse over your T and it'll show you very similar information. Okay, I'm going to flick back to, I spent about a half hour 45 on that, so or 35 minutes on that. So I'm going to skip back and kind of start at the start here with regard to our Python materials. And just again, I'm going to go through them quickly because there's videos for all this stuff, and that should cover most of these concepts for you. I like to go into a bit more detail on these things when I'm doing these live sessions, and I don't want to just say word for word or retread all of the information that you already have access to. I'd rather it be used more as a kind of extension and learning a bit more about these things and showing you how it works in PyScripter as we go. This question and answer section was from last semester, last quint, and I see I need to update this information here. But it does give you some general information on what final projects look like and what students have done in the past and what are the exams going to look like. And it's good reading. So I'll update the dates, but it'll take you 30 seconds to read that. I would. Now this is important. There is a textbook that is a free textbook, and we are using it for reference only. That means if you're maybe struggling with a little piece of code or you can't remember exactly what to type, you can use this textbook to help you out. But we're not doing anything specifically from the textbook. I included it in here because it's free and because it is an excellent resource. This is how I learned how to code in Python from scratch. I started working with this textbook and something called Code Academy Online, and it got me through the basics. And then from there, I was able to branch out a bunch more. It's a big textbook. It's 244 pages, but it covers a lot of ground. And there's a good table of contents in it too. So, if you're struggling with something in particular, you could just go to the table of contents and say, I'm having trouble with variable names. Okay, variable names, page 9. So page 9 of the textbook, which is not page 9 of the PDF. So if I go down and find page 9, that's 2, 3, 4, 9, 7, 8, 9. Okay, then this variable names right here, and it'll tell you how you name your variables and what are the legal names and what are the illegal names. And it does that for every single concept that we're going to go through in this class, but it does it in a lot more detail than you need for this course. So again, use it as a reference. But if you're going to the textbook and you're hoping that it's going to follow in the same order as the way I'm teaching the class or the materials I have in the class, it's not. So we're not using this as our primary reference. This is sort of extra reading, extra help. Not required, but it can be helpful. Okay, just like every other unit, it's going to start with point 1, point 2, point 3, just going in order. I'm going to intersperse the live session recordings. Not everybody attends the live sessions, so I always record them and I always post them in the right spot. So as we go along, these are from last Quint. As we go along, I'm going to replace these with the new versions. If you're moving ahead, and there are several people in the class that are moving ahead, I've got somebody that's just about done. I left them in there so that they would have some live sessions to draw to help them out, even though we haven't gotten there yet in the course. So those will kind of slowly be replaced as we work through. And I've also got, in addition to my 4.1, 4.2, those are sort of the major concept areas. I've also got a bunch of these little web links and notes about things that you need to do in the class that just give you a little bit more of a description. So for instance, this one, a note on using input in Python version 3. Somebody asked a question about it because they had an old version of Python, and you could print things just by typing print and then quotes, whatever you want to print. That would work in Python version 2, but it doesn't work in Python version 3. And we will all be using Python version 3. Okay, so this was just a bit of an explanation as to why you have to do it this way instead of this way, and then how to do a basic input statement if you're struggling with that. It gives you a bit more information on that. So make sure you go through those. They're very short, most of them, and they directly address things that you need to do in your programs. So frankly, I shouldn't have people emailing me asking me, how do I do an input statement in Python? Well, A, it would have been done in one of these major sections, and B, there's a specific learning resource right there about how to do an input statement. Now, if you've gone through this and you still have questions about it, that's a different story. But if you don't know how to do an input statement because you didn't look at the learning resources and you didn't read this over, then you haven't done your job. So make sure you are doing that. And this is very similar. Some of them are internal. So this one, I have the information right in the website. This one takes you to a different website. And but I mean, it's helpful information, and that's why I include it. This one is also internal, so you probably don't know what modulus is right now, but we will learn that in our class. And I also have a video here, and I say, hey, at the 1815 mark, if you're still struggling with the idea of modulus, go to this video, look at the 1815 mark. It'll give you a bit more information. So you're never going to be for a lack of resources in this class. There's always resources that I have put in here, that I have made, that I have pointed to, and you can find resources on your own too. You guys know how to use Google. So lack of information should never slow anybody down in this class. There's a million different good tutorials on how to do these things. If you don't like mine, you can certainly go find another one. I don't take it personally. I've just done my best to kind of build and collect what I think has worked most effectively over the years, and that's what I base my course on. Okay, and it's like that the whole way through the unit, and your assignments are listed in the same way they normally are. So nothing new there. Okay, so let's just get right into 4.1, Introduction to Python. So I have a video for each of these, and the video is going to match up with the slideshow. And I don't want to retread too much ground on these, but I'm going to go through it quickly. Make sure you do go through the tutorial videos because they are different from what I'm doing right now. Zoom this out. Okay, so just a quick run through of what some of these things mean in a bit more detail. Python is useful as a scripting language. They're small programs, and they're targeted towards small and medium-sized projects. A lot of large corporations use Python, but there's very few that use Python alone. Most of the large corporations have programmers in many different languages, and they pick a language that'll work best for whatever they want to accomplish. So, a Google would definitely use Python in a lot of their applications, but it's not the only thing they use. They're going to use Java, and they're going to use C and Mobile C and things like that. So rarely is a computer programmer just going to work in one language. They have to be reasonably proficient in several of the big languages. And again, the nice thing about learning the fundamentals and those 5 basic principles behind coding is that they don't change. They don't change across different programming languages. All of those ideas are still in each of the programming languages, and all of those things and processes can still be accomplished. The only thing that changes is the keywords and the words and the stuff you type out. And that I refer to that as syntax. So once you understand how to use loops and how to use conditional statements, if, elif, else, you're going to see those in every single programming language. The only difference is you might have to type out different words to make it work. So Python is becoming very, very popular with both individual people who want to code, just learning code for fun, for universities and technical schools to introduce students to programming languages, and also for big enterprises like Google and YouTube and whatnot. I don't know if Yahoo is around anymore. Large online games, morgues, things like that. It's become much more popular because it's a simple language to use, and it's very flexible, and you can do a lot of stuff with it. So it is definitely worth learning. There's certain languages, Java is one in particular, where it looks so daunting when you load it up the first time. It scares a lot of beginners away because you would have basically a page worth of code just to print out hello world on the screen, whereas in Python it's one line. So that's one of the reasons that Python is typically used as a beginner language, because it's very simple to understand, it's very simple to run, it's very simple to test, whereas Java is great at a lot of the things it's used for. It probably was and maybe still is the most used programming language in the world, but it's more difficult to get into, and there's a lot more things you have to understand about syntax and structures before you get into it, and it can scare beginners away. So that's why I always start with Python, and a lot of universities and tech schools are starting with Python now too, because they're finding if they just dive right into Java, students get overwhelmed and they drop out. You need to understand the difference between a compiled language and an interpreted language as you move forward. A compiled language is basically something that needs to be processed before it's run. So when you're programming something in Java, when you want to test it or when you want to run it, you have to send it through a series of steps that will basically test the entire program, set it up properly, and then you run it on something called a virtual machine. And anybody who's got a computer has probably seen in the past that they've had to update Java or they've had to install Java or whatnot. Java is a program that actually has to run on your machine, and it takes these little compiled programs, which are full of files and folders and all sorts of stuff that a Java program needs to run, and it basically tests it and builds it and gets it ready, and then that whole package is run at one time. So it takes longer because it has to do a whole bunch of stuff before you're able to run it and see the output. Nowadays with computers, it happens much quicker. But it has to be processed by your Java program and built in such a way that it can be run in a virtual environment. Whereas an interpreted language is run line by line on the fly. Okay, so when we were doing Reborg and when we were doing Scratch and Python, it just runs things from the top step to the bottom step, and it doesn't need to process it a whole bunch before it runs it. It just runs the code line by line. Whereas Java, you would take your program, compile it, go to the environment, and then see the output. So it's a lot simpler, but when it's running, it's slower because as it's interpreting it line by line, it has to do kind of all that work in a step-by-step sequence, whereas a compiled program is kind of optimized, so when you run it, it can run a lot faster. The downside is you have to do all that compilation, or the computer has to do all that compilation before you can run it, before you can test it. So there are some trade-offs, but by far Python is simpler, and any of the programs that we're going to be doing in this class will run very quickly. Anyway, it's not going to be hard on your machine, so it doesn't really matter that it's an interpreted language. It's simple, it runs line by line, it is very straightforward. That's why we use it. But it is important to understand that some programming languages require stuff to be compiled ahead of time, and some languages like Python, you can just run step by step and get immediate results. By the way, Java is not the same thing as JavaScript. I don't know why, frankly, I don't know why they named two programming languages in a similar manner. But Java, if you understand how to program in Java, it doesn't transfer at all to JavaScript and vice versa. They're very different. But we're not working with either of them in this class, so don't worry about it. Okay, so like I said, this is an interpreted language, which means you have an interpreter. Now, when I showed you PyScripter and Thoni, those are the integrated development environments that include interpreters. So when I was pointing down to this section down here where my output is, this is actually the interpreter right here. You can code up here and run your programs, but you could also just go down here and you can get it to do stuff. So if I just go down here with where these little arrows are and I say, hey, print hello, as long as my syntax is correct and I hit enter, it'll print hello right there, right? But I can also do the same thing up here and say print hello and save my program and load it and run it again later in the day, and I get the exact same thing. So if you just want to test things out quickly, there's no problem with you just testing something down here. But if you want to make programs that you're going to save and come back to later and reload and whatnot, you should be doing all your coding up here. Okay, I don't think any of my students ever actually use this interpreted section. Maybe as a calculator sometimes, but most, because we save our programs, we hand them in, everybody does their code up here. But our code is simplistic, so it doesn't take any more time for us to code it up here and test it or run it than it does to do it right down here. Computers are so good nowadays, they're so fast. Doesn't make a difference. Maybe it's marginally faster when you test it down here, but not enough to make a difference in my mind. Okay, so when we refer to interpreter, it's just the section that's running the code line by line. Okay, now debugging your code, we went through F7. Usually it's F7, sometimes it's F9 or F5. Okay, so the first thing that you need to do, and by the way, when you're going through these live sessions or watching the videos, you really should have PyScript or Thoni open, and you should be typing these things in and testing them. It's the best way for you to take what's going on in the videos and what's going on in these live sessions and actually learn it and practice it. You have to be typing things in. You got to be trying things out. You got to be doing the work. You're not just going to remember it, and it's not going to magically make sense. You have to practice it. You have to work with it. Sorry, Jeanette had a question here a while back. Can you make a square on this or just words? Sorry, I think hopefully I addressed that earlier. We're just going to be using words, numbers. Now, if we're drawing things, we're going to be drawing things using characters, ASCII characters. So yes, you could make a box, but it's not going to be like in Scratch where you had a pen that went down and then drew a box. Okay, so we're working now in sort of a hard-coded syntax, and it's going to be way less visual than what you've seen before, because now we're doing quote unquote real programming. And then if you have a strong understanding of these fundamentals, then when you actually get into graphical user interfaces and things like that, you'll know what's going on behind the scenes, and you'll be able to actually adapt and change and build programs that show you things as well. But no, this is going to be largely numbers, letters, words, sentences, things like that. So print hello world. The important thing to know about Python in any language is, and Reborg included, it's got to be perfect. You can't leave out a bracket. You can't leave out a quote. You can't leave out a comma. You need to make sure that your syntax is perfect. If you have a capital P on a print statement, it will not work, and it will give you a syntax error. So if I flick over quickly to PyScripter and I try to, let's make this a little bigger, print hello, and I leave out a bracket, okay, and I try to run it, it breaks. Okay, if I have a capital P instead of a small p and I try to run it, it breaks. Print is not defined because print doesn't mean anything with a capital P, only print with a small p matters. And you should be used to that from Reborg by now. It doesn't matter if it's a comma or a little space or something like that. If your code's not perfect, it's not going to run. And you'll get these error messages right away. So you got to be your attention to detail has to be high, and you have to be able to troubleshoot things with a great degree of accuracy. Usually, if you make a mistake, it's not that difficult to find out where your mistake is because the program generally does a pretty good job of telling you where it is. So in line 1, it says you tried to say print hello, and there's an unexpected EOF while parsing, end of file while parsing. You don't need to know what that means. All you need to know is my error was on line 1. Here's what you typed in, and here's a little arrow pointing to the thing that's possibly messed up. Oh, I forgot a bracket. So when I add my bracket in and I run it again, now it works. Okay, but there's no forgiveness on that whatsoever. If you make a spelling mistake or a capitalization error or something like that, it will not run. So when you are printing something, you need to have print lowercase, you need to have an opening bracket. We're kind of used to that from Reborg. Then anything that you want to print out as text has to be inside either single quotes or double quotes. It doesn't matter which one. So anything between those two quote marks, okay, is going to be printed out. And then you also have to have the end bracket. Zion, I will get to that in a bit. I'm just going to get through the basic print stuff first. Okay, now this is important. Everybody needs to program in Python 3. There was an older version, Python 2, where there were some slightly different ways of doing things. We are using Python 3 for this entire class. And if you followed the instructions when you're installing Python, you should be fine. It doesn't matter if it's 3.1 or 3.2 or 3.9. As long as it's got a 3 in there, you're good. Anything before that, you're going to run into some problems. And this is one of the main differences that you'd see in this course. There's a lot of other differences, but most of them aren't at a beginner level. But this one in particular, in version 2.7 and below, you could print hello world with quotes, but no brackets in it would work. That doesn't work in 3. So you don't want to build your programs in 2 and then submit them to me, because I'm going to test them in 3, and if they don't work in 3, they're not working. So that's the one you'd notice most frequently. It's become less and less of an issue over the years. I have had maybe one student in the last couple of years that accidentally used Python 2, and it wasn't a big deal. But I always want to bring it up. Okay, so we're talking about the print statement, and I showed you how to do a print statement. If you just want a blank line, you just put the brackets with nothing in between them. That'll print a blank line. You could also just put empty quotes inside this bracket. So if I go to here and I do print, and then I just put empty brackets, and then I put something after it. Let's say I put something before it and something after it. So I'll print before, and then I'll print nothing, and then I'll print after, and then you can see how that plays out when I run it. So you see I've got before. Whoop, let's do that. I've got before up here, and then I got a blank space, a blank line, and then I've got after. So you can print out blank lines by doing that, and you can also do it without the quotes. It'll do the same thing. So that's printing out empty lines, should you need to do that. Strings can be started or ending with single quotes or double quotes. And for the first assignment, you're going to need to know what an escape character is. An escape character is a backslash in this language and lots of others. There's certain characters that mean something in a programming language, but what happens if you actually want to put it inside a test string or test words or sentences or things like that? Sometimes you have to put in what's known as an escape character. And these escape characters come before the thing that you want to show up. And this is an example of that. Let's say we want to print out, suppose 2 swallows, and then we want to have quotes, double quotes inside the thing that we're printing out. Okay, now that could be difficult, because if the program sees double quotes, it might think that this is the end of the string right here. It might think that I only want to print out suppose 2 swallows because I've got quotes there that end it, right? I've got quotes to start it, and then these might be quotes to end it. But I don't want to end it there. I just want to have the quotes show up in my text string. So by using this little escape character before it, it doesn't print out that backslash, and it will print out that quote. Same with this one. It will not print out the backslash. It will print that quote mark, and it ignores it as far as code is concerned, so that when it gets to the very end and finds the last set of quotes, it knows that these are the ones that are determining whether or not we should end the print statement or not. So that comes into play right here. Let's say complete nonsense sentence, but let's say that I wanted to have quotes around land. If I put a quote there, it broke my code. You can see it's got a line here. It's saying that's an error. And the reason is there's an error is because it thinks that this is the beginning of what I want to print, and it thinks that this is the end of what I want to print, and it never gets to this one. So if I actually want to show quotes inside, I have to use that escape character so that it ignores those quotes. Wrong with this index there. There we go. Sorry, I had forward slashes. It should have been backslash. So now it'll run, and you'll notice that the word land has actual quotes around it. So by putting, and you also notice that you don't see any slashes down here. So it's basically its way of telling Python, the next thing that you see, you're going to want to print it. You're not going to want to use it as Python code. So it's basically an instruction to Python saying, hey, ignore that thing right after me, so that it ignores these two middle quotes, and then it knows that when it hits this end quote, that's the actual end of my print statement. Because if I don't have, even if I miss one of these, see, it's broken again, because it thinks now, it ignores this quote, but it sees this quote and it thinks that's the end, and then it doesn't know what to do with all this stuff after it. Okay? So that's what escape characters are, and that's one thing that's going to come up on the first assignment, because I ask you to draw stuff, and in some of the stuff you need to draw, you need to actually include those. So if you want to draw an escape character, okay, if you want to print an escape character, sometimes you're going to have to do two quotes or two escape characters in a row. Okay, see how it only printed one here? What happens if I have three? What happens if I have a forward slash? What happens if I put a backslash before a forward slash? Okay. So these are things that you need to test out, because it might come into play when you're trying to draw things. Zion asked me, what about that first assignment where you're supposed to draw an egg or something like that? You actually have to do that with multiple print statements. So it's basically creating ASCII art. Those are just underscores. And then, maybe I'll put that character in, put the letter A in. So I'm actually just drawing things. Oops, I'm drawing things using multiple print lines. Okay, there's no draw feature in this where it's going to automatically do it. You have to do those first couple by hand, try to make things line up. It's mostly about formatting and making sure you understand how to use escape characters. And then maybe for this one, I'll put another underscore and kind of make it a rough box, so that when it's not going to look great, but when I print it out, made myself sort of a rough box there. Probably better, would have been better to do this. Might look more like a box. So you have to do it manually, and you're going to have to work with things like how many spaces do I need, and where do the spaces need to be. And so how am I going to draw an egg? How am I going to draw a stoplight? Well, a stop sign. Basically, you're doing it by hand. You're not missing any hidden draw features or anything like that. It's using print statements to make things look a certain way inside your code. Hopefully that answers your question there, Zion. Another way that you can handle the quotes thing is you can actually have two different types of quotes in the same program. So let's say again that I wanted to print out quotes inside my drawing. If I start with one quote instead of the double quotes, and then I put something inside, there should be double quotes here. So if I put double quotes inside, because my print statement started with a single quote, it looks for another single quote to end it. So the only single quotes in this line are at the very beginning and at the very end, which means that these double quotes in the middle, will actually just be printed out. So if you start with a single quote, you have to end with a single quote. If you start with a double quote, you have to end with a double quote. So when I print this out, it should print this, and it should include the double quotes when I print it out, and it does. And you can do the exact opposite of that. If you start with double quotes, you could put single quotes on the inside as long as you end with double quotes. So because it starts with double quotes, it needs to end with double quotes, and anything inside will just be printed the way you've got it there. So when I run this one, now you'll notice that I've got single quotes printed out. Okay, but you have to keep them in the right order. You can't do single quote or double quote, single quote, double quote, single quote. That won't work. Whoops, that'll cause an error. Notice this won't work. Okay, because I went double, single, double. Okay. Like putting it, you have to put a box inside a box, right? So this would be one box, and then the double quote section would be the big box. So you have to be able to follow them up in logical order. All right. Indentation and white blocks work exactly the same way as it is in Reborg. When you are making functions, when you're doing loops, any of that stuff, it works exactly the same as it does in Reborg. So, you know, for instance, if we're doing an if statement, I'll do x equals 5, and then down here, if I do an if statement, if x equals 5, now you'll notice it does it automatically, but you have to have it indented. So print if x is 5. And then your else has to line up with your if, and then you have to indent your else to print x is not 5. So just like in Reborg, it's only going to do one of these things or the other. It's either going to do the if part or it's going to do the else part. Okay, just like in Reborg, but it has to be indented properly, and that's indentation is done. It either happens automatically. If you put in an if statement and you're using PyScript or thoni, it'll try to force you to indent it properly. But you could also do it just by hitting the tab key, and every time you hit the tab key, it goes in one more further indent. So this, when I run this program, it's going to check, is x equal to 5? It is, so it should print x is 5. Okay. And then if I change the value of x up here, if I make it 6, and I say, is x equal to 5? Well, that's false, because x is equal to 6, which means it's going to do the else part. It's going to print x is not 5. So the white space works just the same way that it does in Reborg. You should be familiar with it. And you can also nest things inside. So you'll notice here that I've got an if statement inside an if statement, and that's fine. This if here, okay, then it goes here and it checks this one, and then this is indented underneath this one. So the print statement belongs to the if x equals 6, and the if x equals 6 belongs to the if x equals 5. So that's the exact same as Reborg. You can put any structure inside any other structure. You can do while loops, okay, and then whatever's under here would be, this will end. Okay, so you can have as many things inside as many things as you want, just like Reborg. Okay. I don't even know if my program makes sense anymore, but the idea is make sure you're indenting things properly and make sure you understand what belongs to what. So because this else is lined up with this if, okay, those are sort of on the same level. Then I've got an if by itself, and then I've got a while, and then I've got a print high and a break that are both inside the while box. Just like Reborg. I'm not going to go over all that stuff because you need to know that from Reborg. And again, I chose Reborg because it uses Python, so a lot of stuff's very, very similar. So make sure you're indenting. Okay, so the exercise, this is what Zion was asking about. Make a program to print this in Python. You want to, make an egg and a saucer and a stop sign, and you got to do it manually. So we're talking you have to do a bunch of print lines just to get practice with the print statement. Okay, so how am I going to make the top of the egg? Well, I should probably use underscores and spaces. And, how am I going to make the egg part? Well, it's probably going to be a slash here and maybe a slash here. I might need 2 escape character, and then you just build it line by line, and eventually when you draw it out, it should look like an egg or a saucer or whatever it is you're supposed to draw. So no magic command. You just have to use print statements and space and characters and stuff on your keyboard in order to figure those things out. So that's 4.1, and that's just intro stuff. Looks like I'm at about an hour 10. I'm going to start 4.2. It's reasonably short as well. But if I get you through 4.1 and 4.2 today, you should be in great shape to start playing around with it on your own. Okay, so variables, expressions, and statements is 4.2. Variables we're familiar with because we used them in Scratch. We didn't use them in Reborg, but we used them in Scratch. Whenever we were storing a score or we were keeping track of time or something like that, we used variables. So you should be familiar with the concept of variables. Okay, so when you are making a variable or for the first time, it's basically called declaring. So if you see that word declaring a variable, it means I'm just creating a variable. Okay. Now it's very, very simple to do in Python. In certain other languages, you would have to have things like, like this, dim int, dim, 5, 6 as int, integer or something, blah blah blah. And it might be a lot of writing for a very simple concept. In Python, all you have to do is create a variable name and then tell it what you need to store in the variable. So for a variable name, I might say name equals, and then I'll just put my name, Brennan. Age equals, and then 42. And then, so those pieces of data are stored in the variables, just like we would have stored score 1 or score 2. Score 1 equals 99. I don't know what score means in this case, but you've stored stuff in variables, and you need to know how to work with variables because variables are how you store information. You can't just hard code everything into your program. If I wanted to print out Brennan 4999, okay, I could do it by doing this: print Brennan, print 42, print 99, and it'll work. Okay, Brennan 4299. But what happens if I need to change something? What if I changed my name or I need to run it for a different person? Then I have to go back and I have to change all of these things and pretend that you have 1,000 of these. Do you really want to go back and change every single one of them? You don't. That's why you use variables. So instead of printing and typing in or hard coding in what you want it to print, you're going to refer to a variable. Okay, so I want you to print whatever is stored in name. I want you to print whatever is stored in age, and I want you to print whatever is stored in score 1. So it'll still print the same thing, but now I have the flexibility that if I want to change the score, I just have to change it in one place, and then it's reflected. So for instance, let's just say I had this score more than one time. Let's say I had this score a bunch of times. Okay, and this is only, 14 times, but you can imagine a program that's got, 10,000 instances of whatever this score is. If I have a variable, okay, so I could have gone print 95, print 95, print 95. I could have done that 14 times, but by having a variable and storing the score in a variable called score 1, I can go back and change it at any time, and instantly the entire program is updated. So you have to be able to use variables, otherwise you're only going to be able to run your program once, and every time you want to change it, you're going to have to manually change every piece of it. If I want to change my name and shorten it to Bren, change my age because I just turned 43 or something like that, I just change the variables and everything else updates automatically. So variables are super important, and you have to know why we use them, and you have to know what type of data you're dealing with, what to store, how to store it, when to store it. Now, when you are deciding what is stored in a variable, we use one set of equals sign. So for this way, x equals 2, Python automatically determines what it thinks the variable is. This is referred to as a data type. I'll just maybe try to demonstrate this a little bit more right here. Okay, so comments are the same, by the way. You can use the triple quotes, or you can use the hashtag, doesn't matter. So what we're dealing with is data types. And these are the data types that we're going to deal with in this class. Integers, which you will recognize from math. floats, which might be a new term, but it's really just a decimal, anything that's a decimal number. Integers, strings, which are words, characters, sentences, paragraphs, and Boolean, which is true or false. And you've seen all of these before, with the exception of floats. You've used integers in Scratch, but you didn't necessarily refer to them as integers, but you used numbers without decimals. Some of you did use decimals, which would have been a float. Strings are words, and Boolean is true and false. In Python, it's true and false. So when you type something in and you say, you make a name or a variable name, and then you assign a value to it, Python automatically determines what it thinks that value is. So for instance, if I put in a variable called my name, and I say that is equal to quotes, Brennan, Python says, hey, because I see quotes here, I'm going to assume that that's a string because it's a word. Okay. And if I put in something called my age and I put in 42 with no quotes, it says, hey, you typed in a number with no decimal and no quotes, which means I think it's an integer. And then let's just say my score has a decimal. Let's say 99.6. Okay, so Python would look at this and would say, well, because you stored 99.6 in my score, well, 99.6 has a decimal and there's no quotes, which means I think this is a float or a decimal. So when I look down here, if I run my program, yeah, I'm not going to print anything. I'm just gonna run my program. If you look down here, I'm just gonna run it first here so I can update this. It says, this is what I see in your program. I see a variable called my age. That, to me, that looks like an integer, and the value of that is 42. I see my name, that's str, which is just short for string, and it's equal to Brennan, the word Brennan, or the name Brennan. I see the variable that you created called my score. I think that's a float because it's the number 99.6. So it's very simple for you to create variables and store stuff in variables in Python, whereas in other languages, it can take a lot more time, space, and typing. Now, you can force it to be other things and we're going to get into that much more when we look at when we get into Unit 4.3. But anytime you include quotes around something, it's going to think that it's an integer or that it's a string, even if it looks like a number. For instance, if I put quotes around 42, it thinks that's like the word equivalent of 42 or the character equivalent of 42. So if I run it again and I look down at my variables, now if you look at my name, my age, sorry, it says, I think this is a string, and I think that the string is equal to 42. And the reason it says that is because I've got these quotes around it. And it would do the same thing with this. So if I run it again, it's going to say, I think my score is also an integer, and it does that because it's got quotes around it. So it would just be like writing 99.6 in a notebook, okay, as opposed to using that number for math. You can't use, I could no longer use 42 for math. So if I try to do 42 minus 10, if I try to make my age 42 minus 10 and then print out my age, error. It doesn't know. It says I can't subtract 10 from a word. I have no idea what to do. Whereas if I get rid of these quotes and it says, okay, I recognize 42 as an integer and I recognize 10 as an integer, so my age is actually equal to 42 minus 10, which is 32. So if I print my age, it'll say, well, I know how to subtract two numbers, and it'll say your age is 32. Okay, and now you can multiply it too, right? You can do any operation. You can do 42 times 2, divided by 5 plus 10. And then because these are all numbers, integers, it can do math with it and give you an answer, and you can even put decimals in there. But as soon as you put in something that looks like it's a quote, it says one of these things is a string. And now, as soon as you put a word in there, it's basically like you tried to do math with your name instead of numbers. So it's really important to understand that and make sure you're dealing with the right type of data whenever you're doing calculations. Okay? And you can always check that down here by looking at your data types in this variables section. Okay, now when you create a variable, you can always change that variable. It'll always go with the last one down. So if I said my age is 43, And then I said, print add 1 to your age. And then right below it, I print my age equals 44. Okay, I use the exact same variable name. So it's my age here, and it's also my age here. It starts as being 43, but then it changes down here to be 44. And we saw that in Scratch as well. You had a variable, and then you could change the variable by 1, or you could change the variable by 5. So from this point forward, okay, so let's say print my age. So when it hits this first print statement, I'll get rid of the name because it doesn't need to be there anymore. But when it gets to this first statement, it says, okay, you are creating a variable called my age. It's equal to 43, which is an integer. You would like me to print that. I will print 43. And then I've just got a line that says add 1 to your age. This doesn't actually do anything. It's just printing this out so we can see the process. Then I said, okay, I want to take the existing my age variable and I want it to make it 44 now. So I've got the exact same line of code after it, print my age. But because I changed the variable from 43 to 44, from this point forward in the program, no matter how many times I print it or use it, it's always going to be 44. Okay, so stepping through this will probably demonstrate this in a better manner. I'm stepping through my code using F7. Okay, so first line, it's going to say, okay, you want to make a variable, call it my age, and make it equal to 43. Okay, it's an integer 43. Now you want to print it. Okay, that's great. I printed it. It's down here. Now you want to print add 1 to your age. Great, I did that. Now you're going to say, I want my age to equal 44 because it's the exact same variable name. Now, after I run this line, watch what happens right here. Okay, after I run that line, it gets red, and all that means is it's telling you, hey, your program updated the my age, which is still an integer, but now instead of 43, it's 44. So now whenever I use my age in my program after this, it's going to be 44. So I printed it, it's 44. I printed it again, it's 44. So once you change a variable, okay, you can't go back to what it was before. And you can change it as many times as you want. If I want to go down here, I could do my age equals my age plus 1. So all that's going to do is going to say, hey, take what is currently in my age and then add 1 to it. So now when I print my age off, it's going to print 45 because it's going to take the 44, which was the current my age, and it's going to add 1. So in the future, every time I refer to my age, it's going to be 45. Okay, so I printed it 43 up here. Then I added 1, so I made it 44, but I didn't print it. Right away, I said, take that 44, make it 45, and then print my age, and it printed 45 twice. Okay, so be aware of variables, be aware of the data types, and be aware of how you change them and what happens when you change them. Okay, operators. I'll just do operators really quickly. I know we're getting up on an hour and a half here. Don't want to go too much further. Mathematics, you're gonna have a lot of math in your programs here. So let's just say we've got some numbers. I'm gonna say x equals 3 and y equals, actually I'll make x equal 10 and y equals 3. Okay, you can do math and print out the results of math, just like you would with a calculator or something like that. But you have to know that the signs are a little different than what you see. So the traditional signs for math are the plus and the minus, which are the same as they are written on paper. But star is going to be multiplication, and then a forward slash is division, and then that is something called modulus, which you will learn. So don't worry if you've never seen the percent sign in math before. And then exponents is 2 stars. So let's look at how that works right now. So let's do print x plus y. And we would expect that the answer is going to be 10 plus 3 is 13. Okay, then let's do subtraction. So let's do x minus y. We would expect that would be 7. Let's do print x times y. Okay, so that's going to be 10 times 3 is 30. Let's print x divided by y. So that's going to be 10 divided by 3, which is 3.3, 333 repeated. Let's do print. I'm not going to worry about mod right now. I'll do the percent sign later, but we should know exponents. So we're going to do 10, 2 stars, which is above the 8, or asterisks, or whatever you want to call it. Not 10, sorry, x to the power of y. So that's going to be 10 to the power of 3. Okay, 10 to the power of 3 should be 1,000. So let's look at the results we get when we use the operators, the mathematical operators. Okay, we get 13. That was the addition. We get 7. That was the subtraction. We get 30. That was the multiplication. We get 3.3 repeated. That was the division. And then we get 1,000, which was the exponent or power, 10 to the power of 3, or x to the power of y. So you need to know that those are the math signs that you need to use, because there's no division sign on your keyboard. There's no, if you tried to use x like I did right here, it doesn't think of x as multiplication. It thinks of it as x, the letter. So that's an important part of the math. I'm going to show you how to increment and decrement values, and that's just a fancy way of saying adding to your values and subtracting your values. You're going to see something that you would never see in math class, so I want you to see it ahead of time. Let's say I want to add 1 to x, which would be called incrementing x. You want to add to it. I might want to add 1. I might want to add 2. I already showed you this with age. You can do something like this: x equals itself plus 1, or 2, or 5, or whatever. And when I print x, which we've already demonstrated with my age, it's going to start with the original value, which is 10, and then it's going to say, I want you to change it so that it was the original 10 plus 1. So the new value of x that's going to be stored is going to be 11. So when I print it out, it's going to print out 11 because I added 1 to it. It doesn't matter how many times I printed after I changed it, it's always going to be 11. So if you did this in math class, okay, your teacher would slap your hand, because this doesn't make sense with what we know with equations. Because when you're trying to solve an equation, or you see something like this, usually you try to figure out what x is equal. And in order to do that, you got to get the x's on one side and the numbers on the other side. Well, if I want to bring this x to the other side, I have to subtract x from both sides. So if I subtract x from the right side and I subtract x from the left side, I end up with 0 equals 1, which clearly doesn't make any sense in math terms. So you have to understand that what you're seeing here is strictly a computer science programming thing. Okay? And all it means is you're taking whatever x was before this line of code, you're going to add 1 to it, and you're going to store it back in x. And you can do whatever you want with regard to the operation. It can be add, it can be subtract, it can be multiply. If I do x is equal to x times 2, it's just going to take whatever x was, multiply it by 2, and restore it. So it's going to say 10 times 2. So when I print x down here, x was originally 10, but then I'm going to multiply it by 2 to get 20, and then I'm going to store it back in x. So whenever I print x after that, it's going to print 20. Okay? And you can do it with addition, subtraction, division, whatever you want to do. There is a short way, though, and I want you to see the short way because A, I want you to use it because it's more efficient, and B, I don't want you to be confused when you see it. So you could do it this way. And what I will do is I will also make y equal to 10, and I'll show you a shorter way to do it. Okay, so instead of doing y equals y plus 2, what you can do is you can do plus equals back to back, and it'll accomplish the exact same thing. So it's just this is exactly the same process as this. It's just written in a shorter way. So y plus equal 2 is the exact same thing as y equals y plus 2. So when I print out x and I print out y down here, you'll notice that they're both going to be 12, right? Because they're both 10 plus 2. They're just written in a slightly different way. So 12 and 12. And the same thing goes if you're doing multiplication or division or anything. So if you want to multiply x by 2 and then store it back in x, you could do that the same way by doing times equals back to back. So y times equal to, okay, we'll do the same thing. It'll give you 20. Okay, and you can do subtraction. I want to take the original x and and I want to subtract 2. So then you would do subtract equals 2. So x subtract equals 2 is the same thing as writing x equals x minus 2. It's just the short way of writing things when you're incrementing them. Incrementing them means making them bigger, or decrementing them, which means making them smaller. So if I do minus equal 2, it's going to say x is going to be replaced with itself minus 2, so it's going to be 8. Okay, now, I actually have a print y here. That's why I got the 10 as well. So if I just do with the x is now 8. So that is something you're going to see, and I don't want you to panic. It's just a computer science thing. Okay, so long way, which is fine. Short way, which is better. So this is x plus equal 1, which means it takes the original x, which is 2, adds 1 to it, saves it back into x, which means it's going to be 3. This one uses multiplication. X equals 2 to start. X is going to be equal to itself times 3. So 2 times 3 is 6. So after this line runs, x is going to be 6 from there on in. Okay, we went through these already. This is just quick review. Anything without a decimal that's a number with no quotes is an integer. Anything with a decimal and no quotes is a float. Anything with quotes is a string. And the only two words that are Boolean in Python are capital letter true and capital letter false. And you'll notice when you type them in, when you type them into your program, if I just type in print the word true, you notice it just treats it as a string, right? But what happens if I print without quotes true? You notice it turns it green because true without the quotes is Boolean. And I could also print false with a capital. Print true, print false, or print the word true. Okay. This one up here at the very top is just a word. This one right here is a logic statement. It's a Boolean. So you'll be using these, and just make sure you understand that when you use capital true and it doesn't have quotes around it, it's actually different than if it was just the word true. And it also has to have the capital, because if you try to use it as Boolean, it doesn't have a capital, it thinks it's a variable name. So it has to have a capital. So we did this in a computer history part. We did logic tables, right? True or true is going to be true. Print true or false is going to be true. Print true and false, and that's going to be false. So I'm just going to get rid of the word here. Now we're dealing with Boolean logic or Boolean algebra. True or true reverts to true. True or false reverts to true. True and false reverts to false. Okay, so you see what it's printing. It's not printing what's in between the quotes. It's printing the value of whatever this math is. And the math in here is based on those logic tables. If something is true or it's true, the result is true. If it's true or false, the result is true. If it's true and false, the result is false. And we had tons of them, right? We had XORs as well. True XOR. I can't remember how you do XOR in Python. We never use it. But if I did false and true, we know that one would turn out to be false as well. So when we print this out again, the value of true and false is false. So that's why I printed out false as this last one. Okay, that's all review. And you can always tell what type of a data type an object is. You can either look at your variable list. So you can look over here and see what any of these values or variables. Let's say x equals 5 and then y equals pi. Okay, you can look over here, right? Got to run the program first, but you can look over here and you can say x is an integer, y is a string. You can also have Python specifically tell you if you do print and then type and then whatever your variable name is, it will actually print out what the data type is. So this is just me checking what type of data is x, and it says class int. So that's it printing out what the data type of x is. If I change this to y, it's going to print out that y is a string, so class str. So that's how you can just check whatever a variable is. You could also do it without a variable. If you just typed in check and then in quotes hello, it'll tell you it's a string. If you tell it to print the type of 3.14, it's going to tell you that's a float because it's got a decimal. All right. Now, keywords. When you're naming variables, there's words you can't use. Okay, and these are the major rules. It can't start with a number. It can't start with a special character like an exclamation point or a percent sign or a dollar sign. It can't have spaces. Okay, and anything else is fine. It can end with a number. It can have a number in it. It can never, you got mile 8 there. As long as it doesn't start with a number, it's fine. As long as it doesn't have spaces, it's fine. And as long as it's not a reserved word. There are certain words that mean things in programming languages, and we know this just from working in Reborg. We know that while means something. We know if and elif and else means something. We know that the def is what we use to start building functions. We know that means something. We know not means something. So you can't name your variables these things. And it'll tell you that if you try to do it. So if I go over to PyScripter and I try and create a variable called and equals, let's say and equals hi, it'll tell me that and I try to print and, it'll tell me, I don't know what to do with this. This is invalid syntax because and is a protected word. Now you could make it work by putting in and, something. Now you can use the word and in your variable name, but it can't be your only variable name. Whoops, this would have to be and something. So now it'll work. And underscore something is an okay variable name, but and by itself is not. Just like if I tried to do if as a variable name, it would do the same error. It said if is a protected word, so I can't let you store anything in the word if. If you said if a variable equals hi, well then it's fine. It's just those words alone. And generally speaking, you try not to use any of the reserved words even in your variable names. Okay? Now, when you're making variable names, try to make them descriptive. So, if your variable is going to store the name of somebody, you would want to call it my name equals, and then whatever you want your name to be. You will use variables like x and y just because they're short. Oops, x equals 5 or 4. You will use x's and y's. And that's okay, but in general, you want to name your variables effectively. So that anybody looking at your code can just look at the variable name and say, oh, whatever's stored in here probably should be a name. So if I saw my name equals 3.14, I'd kind of go, well, that doesn't really make any sense as a variable name. That should be like pi equals, so like pi equals 3.14 would make more sense there. So name your variables effectively and make sure that they are none of these words. And most people, if you make this mistake, you'll only make it once. We went through snake case and camel case, should be fine with those. Variable names and your file names should be one of these two things. I know that it automatically saved Reborg files as step space 1. That's actually a terrible way for it to be done, and I suspect that at some point the maker of that program will fix that because it's really bad. It's really bad way to do things. You should never have spaces in your file names. So as you are moving into your Python unit, don't use spaces in your file names. Okay, make sure that you're using either snake case or camel case. So for instance, this is a variable name with no spaces would be fine. You could say this is a variable name equals hello. Or if you're saving your file, this is a file name .py, no spaces is fine. Assignment1.py, no problems. Usually, especially for variables, if you're using camel case, you always start with a lowercase letter. Okay? And we'll get into why that is, but for now, you should be naming your variables like this. You should be naming them my variable equals 5 instead of my variable equals 6, or even worse, my variable equals 7. Usually you want that first letter to be, this would be the best. Whoops, the top one would be the best. That would be snake case or camel case right there. Because a capital letter or a capital name actually has a sort of a special meaning for programmers. So and you don't have to know what that is yet. We'll get to it later. So when you're naming your variables, either use this or use that. Okay, camel case or snake case, whichever one you like is fine. But be consistent and make sure that you don't have spaces. Expressions are just like in math. It's things you can do with math really. So x plus 5, y minus 3, and you can do certain math with words, but not all math. I'll just give you a quick demonstration of that. I know we're getting on a little long here, trying to do my best to get through it. Okay, so let's say we have word 1 equals hi space, and then word 2 equals there, period. You can actually add words, but you can't subtract them or divide them. You can add and multiply them, which is kind of cool. Let's just say I wanted to print out hi space there. Okay, I can actually use addition for that. So I could print word1 plus word2. It's called concatenation, which just means putting things together. You are allowed to add strings. You are allowed to concatenate strings. So what this is going to do is just going to print out hi, because that's word1, and then it's going to print out word2 right after. It's going to print hi there. So when I run this, the answers or the output's going to be hi there. And it's got a space in it. It's got a space in it here because I put a space up here. If I didn't put a space up there, then it would just print back to back hi there. So you're allowed to do that. You're also allowed to multiply words or strings, but you can only do it with numbers. I can't multiply word1 times word2, but I can do word1 times 3 or 5 or whatever. What it does when you multiply a string is it just repeats it that many times. So if I'm printing word1 times 6, it's just going to write hi space 6 times. See? Okay, but you could not do word1 times word2. It doesn't know how to do. I don't know how to multiply a word by a word, but I assume that when you see a word times 5, what it really means is I want you to repeat it 5 times. So that's just one of those things that's kind of built into Python. So you can do addition by adding 2 words together. You can do multiplication only by an integer. Okay, you couldn't do it by decimal or anything, wouldn't work. And you can never do subtraction. You can't do word1 minus word2. It doesn't know what to do with that. I already tried to do that, showed you that before. You can't do word1 divide by word2. It doesn't know how to divide words. It doesn't know. So anyway, plus is sort of a special circumstance. But even if you do use addition, okay, you can add 2 words together back to back, but you can't add anything else to it. So I could not put a 5 after it. As soon as I try to do that, it says, now I don't know what you're doing. I knew how to put hi and there together, but I didn't know how to add the number 5 to that. So if you're using plus sign with strings, they all have to be strings. I could add in the word by, as long as it's in quotes, it's string, right? So I could add in anything within the string. I could put in a number, but remember, because it's got quotes around it, it thinks this is a string. It doesn't know how to do math with this. So if I do that, it'll work now, okay? But that's the only reason it works is because I made sure that the things I was adding to it are strings. Now, here's an example of how that might go wrong with you for math. Remember, data types are important. If I try to print out 2 plus 3, it should print 5. Those are both numbers. But watch what happens when I print out quote 2 plus quote 3. Okay, this is why this is important. The top one was printing out an integer plus an integer. So it says, well, I know the number 2, and I know the number 3, and I know I can add those and get 5. The second one is basically saying, oh, okay, you gave me the word or the character 2, and then you gave me the word or character 3, and when you give me 2 strings to add, I put them back to back. I don't do math with them. So that's why I got 23 for the second one. It just took the 2 and put it back to back with the 3. Whereas if you don't have the quotes, it says, well, those are integers, and I do integers using the regular math that we see in high school. Can we do word1? Sorry, just checking in my messages. Can we do word1 equals word1 plus word2? Well, word1 minus word2 wouldn't work, but if you're asking, and I think you are, can I do this? Word1 plus equals word2? Yes, you can. All you did there was you said, whatever word1 is, I want you to take it and add word2 to the end of it. So now when I print off word1, keep in mind, though, this changes what word1 is, right? So now if I print off word1, it's going to be back to back because I changed it. Whenever you do this, the plus equals or the minus equals, you're changing what word1 is. You're saying take the original, add something to it, and then resave it. So word1 is no longer hi at that point. From this point forward, word1 is going to be hi there. You can't do subtraction because remember, it doesn't know what to do. it doesn't know what to do with subtraction with two words, and you can't use multiplication because they're both strings. So the only way you could do that is like this. And remember, this is just the short version of word 1 equals word 1 plus word 2. Okay, that's the long way. That's the short way. So yes to the one for the first thing, and you already figured out no to the second thing. All right. Okay, bed mass. Computers follow bed mass, and so it's going to follow brackets. 1 plus 1 is 2. 1 plus 3 times 4 minus 2. It's going to do the 3 times 4 first because of bed mass. So it's going to end up being 1 plus 12 is 13 minus 2 is 11. 7 divided by 2 is going to give you, actually this is wrong. This is not, it's not going to give you 3. It did this in the old version. In the old version, if you printed an integer divided by another integer that would give you a decimal, okay, it would not give you the decimal. It would just cut the decimal off. In the new version, it does print the decimal, so that's good. However, if you don't want the decimal, you can use 2 divide signs. So if I want 7 divided by 3 and I don't want the decimal, I put 2 division signs, and now you notice it just puts 2. The thing you have to keep in mind here, though, is it doesn't round. Okay, so let's look at 7 divided by 4. So 7 divided by 4 is 1.75. Okay, but if I do integer division, that means don't give me a decimal. 7 with 2 divide signs 4. You'll notice it didn't round it up to 2. It kept it at 1. So it doesn't round it. It just trims off the decimal. So you don't have to use that very often, if at all, but it is notable. Anytime that you have 2 different data types, so 7.0 is a float and 2 is an integer, your answer always retains the most accurate number. So the most accurate number is going to be a float. So if you divide 7.0 by 2, okay, you're going to get a decimal, and a decimal is more accurate than an integer. So your answer is going to be a string, or a float, or a decimal. But if you have an operation that has 2 integers and the answer is an integer, the answer can stay an integer. So for this one here, it's 3. 2 asterisks means to the power of, right? So 3 to the power of 2 is 3 times 3 is 9. Okay, because the 2 inputs, the 3 and the 2 are both integers, and the answer is also an integer, it knows it doesn't need decimals, so this 9 would be an integer. So it always takes the most accurate version. If I were to do 3 to the power of 1.5, that's going to give me a decimal. So let me look at that here. Let's print 3 to the power of 1.5, and now you'll notice that I have a decimal. So even though I started with an integer, okay, and a decimal, or a float, because the answer had a decimal, that means your answer is going to be a float because it's the most accurate. 5.196, whatever, would be more accurate than just 5. So it's always going to keep the most accurate, which is going to be the float. We'll worry about modulus another day. I think that needs a bit more explanation. We just talked about this, concatenating words. Okay, you can add words, but you can't add a word and a number. You can't add a word and a float. You can't add a word and Boolean. You can only add strings or numbers, integers, floats, but you can't mix and match them. This is just another example of string concatenation. So in this first example here, x equals 4. So x is an integer. So if you print the words, thou shalt not count to, and then you try to put plus x, because x is an integer, it's not going to let you use the plus sign, so it gives you an error. However, if you print thou shalt not count to, and then you convert x into a string, this is called casting, and we'll probably do this on a different day. If you convert it into a string, well, then it's adding a string to another string, so now it's okay. The way that I prefer to concatenate, and I use it 99% of the time, is I use commas. What a comma does is it allows you to print multiple data types, and you don't have to worry about getting that error. So let's say I have 3 different data types, or 4 different data types. Let's say x equals high, so that's a string. We've got y equals 5, that's an integer. We've got z equals 4.6, that's a float. And then let's also have n equals true, which is Boolean. Normally, I wouldn't be able to print all 4 of those different types on one line. Okay, watch what happens if I try to print X and plus Y plus Z plus N. It's going to give me an error. It's going to say I don't know how to concatenate those because they're all different data types. However, if I use commas instead of the plus sign, I can use as many different data types as I want. And that's why I use commas, right, to separate things in a line, but I can do different data types. So this is going to print all the data types, no error, right? So that's why I use the commas most often. The thing you have to remember about a comma is it automatically puts a space in. So when I print this, it's going to print high, which is a string, then a space, then 5, which is an integer, then a space, then 4.6, which is a float, then a space, and then true. So if you use the comma, you could put a bunch of different data types in. So you know, you could do something like hi, this is a float, and then after that I can put comma, and then which one's my float? Z. And it won't get an error. It'll print out my words, my string, hi, this is a float, and then it had no trouble printing out whatever Z was, which was a float. So that's why I use the comma, and that's why you should as well. Went through this already. You can see that in the videos. I probably went into more detail on this stuff than I should have, but I just want to make sure you're off to a good start and that you have a resource to come back to if you get into your, you get into the assignments or the first couple programs, and I talked about it somewhere. At least you can go back to this video and hopefully find what it is that you're looking for. So once again, probably went a little long, but I usually tend to err on the side of too much information as opposed to not enough information. So we'll end it there today, and that should give you a really good start so that when you move into the videos for 4.3 and beyond, you should be able to hit the ground with your feet moving, so to speak. That doesn't mean you shouldn't go back and watch the videos for 4.1 and 4.2. You need to do that because there's going to be helpful information in there. And if I repeated some of that information today, not a big deal. You're still going to understand it the second time. Maybe it makes even more sense the second time. So do go back and watch those videos for 4.1 and 4.2. But you're at a point now where you should probably be able to, by early next week, have gone through the videos for 4.3 and maybe start working on the first couple of assignments. What assignment is that? That would be assignment number 11, I guess, where you're going to be building, I think, 4 or 5 separate Python programs, starting from something that's really simple and working your way up to something that's a little bit more difficult, but still pretty easy in the grand scheme of things. And after that, we'll just keep moving further and further and further and adding some more commands and ideas. And by the end of the course, you'll be able to solve very complex problems using Python and create good programs. Are there any questions before we sign off? Everybody's good? Okay, as always, don't hesitate to email me if you have any questions. Sometimes I'm going to point you to stuff and say, hey, this is in this video or this is in this live session or you have to read this. That doesn't mean I don't want to help you. That just means I know that the answer is there and you haven't accessed it yet. So if I'm pointing you towards something, take my advice, go read it, go watch it, go practice it. And if it still doesn't make sense, then send me the email, and absolutely I want to work with you one-on-one. Because I do want to help students, but I also, again, your job, my job, if I provide the materials and the videos and the learning resources, there's an expectation, a reasonable one, that you're going to do your job and watch, read, practice, whatever you're supposed to do. Will this be saved? Yep, every live session is saved and posted in the appropriate spot within each module. So you can expect to see this video up tomorrow. Probably right above the 4.1 material. It just takes a bit for YouTube to process it and for me to put it up. So all live sessions are always saved and posted. No worries. And I do that because we typically go into more detail in these than we do in the tutorial videos. The tutorial videos are just the basics, and some students are able to take that and just hammer through the assignments and no problem, and that's great. And some people want a little bit more explanation or whatnot, and that's what we do sessions for. You are most welcome, Jeanette. Have a nice week and weekend. Remember, we don't have session tomorrow because it was a short week. So we're going to have another one on Monday at 1:30. So, Monday at 10:30 a.m. May 31st. So, I don't see you before then, have a wonderful weekend, and we'll see you on Monday. Take care.